Good morning, scientists. Third hour, fourth hour, and fifth hour. Y'all look great today. You are about to finish your first week of online learning, and you're doing great. I know I keep saying this, but I really do miss your faces. Okay, so as you read your Friday, March 27th daily plans in Google Classroom, you'll notice that your warm-up question for today is to make up a short answer question, not an essay question, not a multiple choice question, but one that'll take more than a word or two to answer from what you read and then answer it. We are going to be grading page 4 and 5. Do that in Shobi. The answers will be in the video. I'm not going to stay long on that slide, but you go ahead and pause it and take as much time as you need to correct and make corrections. We're going to be going through the blood vessels keynote, so you are going to need your keynote handouts, and you're going to want to turn those, look like this, to section 3 called blood vessels. Section 1 was all about blood. Section 2 of this unit was about circulation. And section 3, our final section, is about blood vessels. Okay. So go ahead and open your keynote handouts, and we are going to get started. You'll see that your homework for today is, after we finish the presentation, there is a How Blood Pressure Works Edpuzzle posted that I'd like you to do. I'm going to grade that as a completion grade. So I won't take the actual grade that you get, but just for watching it completely and answering all the questions, you will get complete points. Okay. So for grading page 4, go ahead and pause here and make any corrections that you need to make. Then pause here for page 4 and the beginning of page 5. And then pause here. Okay. On to your handouts. So we are talking about blood vessels. So the circulatory system, remember, it's the heart, it's the blood, and it's the vessels. So the circulatory system is what provides the force and the channels, in other words, the pathways, for taking the blood to everywhere in your body, to every cell, to all the tissues, bringing the food, the oxygen, and then, of course, as you remember, removing any wastes, things that are harmful for your body. So the blood vessels are hollow tubes, and they circulate your blood. You have the arteries, the veins, and the capillaries. I'd like you to pause here for a minute and look at these three, the arteries, the veins. Here's your artery, your veins, and your capillaries. And I'd like you to think about what is similar about the three and what's different. We're going to talk about arteries first. Oops. So with each contraction or squeeze of the heart, your blood is pumped out of the heart through all of these blood vessels, the arteries, capillaries, and then the veins. And they each three have their own unique job. And remember, we talk all the time about how structure is designed, the way that everything in your body is designed is specifically for the job that it has to do, the function. And the same is true with the blood vessels. So the artery's job is to carry blood away from the heart. Each of your ventricles, remember those are the two lower chambers, those are connected to an artery. See if you can think what artery is connected to the right ventricle. If you said the pulmonary artery, you're right. And what is the artery that's connected to the left ventricle? And because I'm sure you said the aorta, good for you. Okay, the arteries have thick, elastic, meaning stretchy, made of connective tissue, and smooth muscle tissue. Remember, we talked about the different kinds of muscles, and those smooth muscles were the ones that you find in organs, like your esophagus, your small intestine. The main artery, the largest artery, is the aorta. See if in this picture you can find that aorta. Each region of your body has a system of arteries that supply it with a fresh, oxygen-rich supply of blood. Arteries are tough on the outside, but they're smooth on the inside so that the blood can flow easily. There's nothing to keep it, to hold it up. It's got a strong muscular wall that helps the heart to pump that blood. Veins carry blood back to the heart. Now, veins are different from arteries because they actually have valves, and these are one-way valves to keep blood moving in one direction, to the heart, toward the heart. Remember, there are valves in the heart as well, and the same function is to keep blood moving in the correct direction so that it doesn't back up. Veins receive blood from the capillaries, and they carry waste like carbon dioxide from the cells, and it's therefore low in oxygen or deoxygenated.
Veins contain one-way valves that work in conjunction with skeletal muscles. When the skeletal muscles contract, the valves open, and blood is forced toward the heart. When the skeletal muscles relax, the valves close to prevent the backflow of blood away from the heart.
So you see here a vein, and you can see the valve in there, and then your artery. Capillaries. These are what connect veins and arteries. And like you read in your assignment the other day, the walls of these capillaries are only 1 cell thick, and that's to allow nutrients and oxygen to diffuse into your body cells through those very thin capillary walls, and then to allow waste materials like carbon dioxide to diffuse from those body cells, from those tissues, into the capillaries so that that can then be carried back to the heart. Okay, look at this picture. I want you to look at this, and I want you to see if you can use this picture to help you explain how the respiratory system and the circulatory system work together. When you're thinking about the respiratory system, do you see different parts that you remember as we talked about the respiratory system? The trachea, the alveoli. And as you're looking at this picture, notice your arteries, capillaries connecting to veins. Again, you see here, you've got your veins, your arteries, and the capillaries. Notice in this picture which way the arrows are going. If this picture didn't even have color, how would you know which was the artery and which was the vein? The answer is going to be in the direction that blood is flowing. So what you're seeing here is a capillary wall. And notice that you see blood. There would be arteries here, coming from an artery and then going to the vein. And this is where that exchange of gases and nutrients happen. Again, likewise, if there were no labels here, if there were and no color and just arrows, you would know that this is the artery because it's taking blood away from the heart, and this is the vein because it's taking blood to the heart. You're going to need to know the blood flow pattern in the heart. We're actually going to do some exercises next week that's going to help you remember this. But by blood flow, I mean as blood is coming back from the body, remember, from the upper part of your body, it's going to start in that superior vena cava from your lower part of the body. You don't see it here, but it's going to enter in through that inferior vena cava. It's going to go into that right atrium, the right ventricle, and out the pulmonary arteries. It's going to go to the lungs, which would be here. It's going to pick up that oxygen, and then it's going to come back around because of pulmonary circulation, come back into the heart through the pulmonary veins, into that left atrium, the left ventricle, and then out the aorta to all of the cells of your body. Okay, your pulse. What you're feeling when you're taking your pulse is actually waves of pressure, and that increases and decreases with every heartbeat. You can really feel your pulse where the arteries are closer to the skin, like your neck, your wrist, like you see in that picture. When the pressure is higher or lower than normal, again, messages are going to be sent to your brain, and then your brain is going to send messages that speed up or slow down the heart rate. And once again, we keep talking about the brain, which is in the nervous system, which is constantly getting signals to keep your body functioning the way it should function. Remember, we talked about your brain gets a signal if there's a buildup of carbon dioxide in your body and causes you to breathe faster. Same thing is happening with the heart rate. That keeps blood pressure constant, even, steady, so that enough blood is going to reach all of your organs, all of your tissues, cells in your body, and that the nutrients are delivered to every cell. Now, you're not going to do this now, but after you finish filling in your keynote, your homework is going to be to watch that Edpuzzle video that's called How the Blood Pressure Works. That is in Google Classroom. Okay, continuing on with blood pressure. So when the heart pumps blood through the cardiovascular system, the pressure of the push moves through the blood. So here, you can see as the blood is moving through this vessel, it's pushing on the walls of that vessel here. And the force that's being exerted on the walls of that is called blood pressure. The pressure is highest in arteries and lowest in veins. Why do you think that is? Pause this for a minute, and I want you to think about why would pressure be higher in arteries than in veins? Blood pressure is measured in large arteries. And this is because, as you probably answered, these are the vessels that blood is coming from the heart, that's being pushed out from the heart. the veins, blood is coming back. So there's going to be more force in those arteries. It's expressed by two numbers. The first number is the measure of the pressure, that push, the force, that's caused when the ventricles, remember those lower chambers, when they contract in, when they squeeze, and the blood is pushed out of the heart. Then your blood pressure is going to suddenly drop as those ventricles relax and reload or refill. The lower number is the measure of the pressure when those ventricles are filling up just before they squeeze or contract again. This is how they measure blood pressure, and we're actually going to go into that in more detail Monday, and you're going to learn how to do that. So again, blood pressure is a measurement of the force of blood on those vessels as it moves through those passages. So when the heart contracts, there's a surge of blood, and that's the top number, the systolic phase. And it's going to be higher because that's the push. When the heart's at rest, when those ventricles are refilling, that's the diastolic, the lower number. It's going to be smaller because there's not as much force as those ventricles are filling up. So this is what you're hearing when you hear a pressure like 120/80. This is what I'm gonna post on Monday, where you're gonna learn how to take blood pressure.
We achieve at
And again, because of the fall, there is disease. Sometimes your circulatory system isn't working the way it's supposed to, the way it was designed to work. So any disease that's going to affect your circulatory or cardiovascular system would be, it could be a disease affecting the heart, the blood vessels, or the blood. It is called cardiovascular disease. It's actually the leading cause of death in humans. Atherosclerosis, this is a condition where fatty deposits, plaque builds up on those artery walls. It can occur in any artery in the body, but where they're most especially dangerous are the ones that are deposited in your coronary arteries. Remember, those are the arteries that are supplying the heart itself. And you remember that app I showed you, what that looks like. If a coronary artery is blocked, a heart attack occurs. And you remember, again, that app that I showed you shows what is happening when a heart attack is occurring. So here, you're looking at, so this is magnified, you can see 10 times. This is a cross section, so in other words, it's like an artery was cut and you're looking into it. And this shows a really clear, wide open pathway where blood can easily flow. Now here, you can see that there's a buildup of fatty deposits so that there's not as large an area for blood to flow. So the heart muscle isn't going to get enough oxygen and nutrients to work, so it could begin to die. Now here, if those deposits continue and continue, then that flow can stop, and that is when a heart attack would happen. Another disease is called hypertension, which is just another name for high blood pressure. And this is when blood pressure is higher than normal most of the time. Now, very often, a person's blood pressure is going to change, and sometimes it's going to be higher when you're exercising, when you're really excited, like when you walked into science class. High blood pressure, hypertension, is when this is a constant, when it's most of the time higher than normal. And what happens here is because the area in those arteries is narrower, the heart has to work a lot harder to pump enough blood through those. So this atherosclerosis, like here, this buildup, can actually cause high blood pressure. A clogged artery can cause the pressure within that vessel to decrease, and then what happens is the walls of the artery become stiff and hardened, and so they don't contract and dilate as easily because they've lost some of their elasticity. Very often what happens is when your heart has to work harder and harder and harder and harder, it can cause your heart to wear out if it's overworked. So causes: being overweight, eating foods that have too much salt, too much fat on a regular basis, smoking, a lot of stress can cause some of this. How to keep a healthy cardiovascular system: you definitely want to keep checkups. You want to watch your diet, exercise, not smoking, vaping,